Hello everybody, long time no see. Today we're going to be looking at a couple of things. It's going to be pretty simple just to kick us back off and get us used to working with the code for this platformer again after the long break. But we're going to look at two things in this episode. We're going to create some hit sparks for the bullet so you can see when we're hitting the wall. Some cool hit spark effects are coming out. And we're also going to make some dust effects that you can just see there. So when we land, dust comes out of the player. But more importantly than that, we're going to learn how you can use a very simple object event in GameMaker to create some simple particle effects such as these. Hopefully it'll fill you with some inspiration, and then you can go nuts and create some really cool, pretty effects very similar to the ones we've created by the end of this. Hope you enjoy it. Let's get started. So I've added and tweaked a couple of little things in between last episode and this episode. First off, I've added a new level 2. So just a quick, very similar to level 1 really, just made some brief changes. Added a couple of enemies in just so that we have another level, since we lost our previous level 2 to the room disappearance bug that was going on with GMS2. It assumes you've got the gun because you had to shoot through the crates in level 1. And speaking of the crates, I also changed the crates to be 32 by 32 instead of like a 48 by 48 that we did before. Just makes it a little bit easier for a few things, and just makes it easier to like place them, be consistent with kind of our level design and that. Decided 32 by 32 is just a bit better. That's it really. I've added a couple of new sprites for the things that we're going to add today. This is my hit spark sprite, and this is what we're going to add in first. So if I play this, you can see it's just like a thing where the same shape as what the bullet is, like this shape. It's a little bit thinner actually, and probably should have made that a bit thicker. But it collides and just sort of expands outwards and then disappears. And this is just what we're going to have play at a speed of 15 FPS when a bullet hits a wall. Okay, so one way you might imagine of doing this is in our bullet object when we hit a wall, changing our sprite to be hit spark, and then when the animation ends, if we are in that kind of hit spark state, we then destroy the object and so on. Problem is that raises a couple of it's slightly more complex to do it that way, because you then have to still care about the bullet technically being a bullet object, and therefore if anything collides with it while it's in the hit spark animation, that might cause a thing to happen, and so on and so forth. So the easiest way we can kind of skip having to care about as many edge cases as possible is to simply make a new object called, we'll call it ohitspark, which is what I'm going to do, and we're simply going to turn our bullet into this object when we collide with a wall. Okay, so I called it ohitspark. I'm going to set it to be that sprite. That'll be in the description with the zip file as always. And what we're going to do is just create a really simple, really lightweight object that just plays this animation and destroys itself, and will be automatically positioned wherever our bullet happened to be. So really there's a tiny amount of code that we need to actually put in this hitspark object. I'm going to add two events. I'm going to add the create event, and I'm going to add the other animation end event. This is a super useful event. I use it all the time for all kinds of different things and reasons, because it just really easily tracks like if your current animation has come to an end. You can do this otherwise by saying like if image index greater than X or whatever, but usually I have a very specific thing I want to happen in animation end, and keeping it in its own event is quite nice. So all I want to do is in the create event, when this object gets made, where the object is never actually being created from scratch. Okay, ohitspark is going to be simply the object that obullet turns into when it hits a wall. Okay, it's actually going to change into this object, so it's going to retain most of the properties that the instance of obullet had. So its X position and its Y position in the room are going to be the same. Its image angle and all that nonsense is all going to be the same. So really I just want to overwrite a couple of things from this object, and that's going to be our image index to 0 and our image speed to 1. Now those are the default values, right? Any instance of an object created by default is going to have an image index of 0, it's going to be on its first animation frame, and it's going to have a speed of 1. But because we're changing an instance of obullet into an instance of ohitspark, we are going to retain the image index of obullet, and we're going to retain the image speed of obullet, which might be different things depending on what obullet is currently doing, because we start from that flash and we transition to that bullet and then we stop animating. So we want to overwrite these, so we set it back to back to the defaults, okay? And that's all we need to do in the create event. In an animation end, all we're going to do is write instance destroy. So when the animation is over, so when those 3 frames I showed you before, if we go to edit the sprite, so when this just comes to an end, when it hits that the blank frame, we don't even really need a blank frame in there, but we have one anyway. When it hits that frame, when it hits that frame and then animates, would wrap around the animation, we just destroy the instance instead. This setup, just animation end instance destroy, in an object, is a really, really quick, easy, dirty way of creating all kinds of wonderful little particle effects and things, okay? Objects themselves are kind of technically a bit heavy in GameMaker. That is, they've got a lot of built-in variables, and they have a certain memory footprint and a certain performance footprint, especially if you have lots and lots and lots of them. But if you're doing things that only show up in small quantities, or you're just trying to get something in working quickly, it can actually just be really effective just to set up an object with very simple behavior that has an animation end instance destroy event. Okay, really, really useful. We'll be using that for both things that we're going to add in this video. So that's everything we actually needed to add to our Hitspark. As I said, it's super lightweight and simple, 3 lines of code. So I'm going to close that now, and I'm going to go up to OBullet. Now you might remember when we set up OBullet, we used the begin step event to do all our collision checking. This is to make sure that this happens before our speed is applied, although I think the step event would have actually gone away with this as well. Before our speed is applied, so that we can make sure that we actually see the final frame of animation. Okay, because if we applied the speed, then checked for a collision, then destroyed the object all before the draw happens, then we wouldn't actually see our final frame with the bullet like embedded in the ground or embedded in the thing that it hit. But we kind of want to do the reverse of that now, because we, instead of actually wanting to see the bullet on its final frame, we want to not see it on its final frame, because that's when we want to change it to the Hitspark. So we don't want to see both at once. So we don't actually need it to be that way around anymore. This isn't super necessary, but just to show you how you can change events from one to the other if you need to adjust timings and things like that. You're going to right click on begin step and go to change event and go to step and select step. And you see that's changed that event from begin step to step, but our code is still exactly the same. Okay, really useful in case you will need to change around things like that for timing purposes and all kinds of stuff. What I'm going to do though is at the moment bullet is controlled by the speed variable. Okay, so this thing is built in, turns green, and it's automatic, an automatic process of an object. As I say, objects can be kind of heavy because they've got lots of automatic processes, whereby every single frame, if you've got a speed above 0 or below 0 or whatever, the object is going to move in its direction by that speed amount. But the problem is we can't control how or when that happens. So I believe by default it happens somewhere between the step event and the end step event, but I want to be able to control exactly when it happens. So what I'm going to do is actually going to go to the gun object where we create the bullet in the first place in the begin step event. Here where we set the bullet's speed, and I'm going to change speed to be SPD, so it's going to be a blue variable that we declare ourselves. Okay, then once I've done that, I'm going to come back to OBullet. Now by default, if I was to load the game and start shooting now, our bullets wouldn't move anywhere because they no longer have the speed set and they just have this SPD thing that doesn't do anything. But at the top here, I'm gonna move our object in its direction by its SPD variable rather than its speed. So how can we do that? How can we replicate that functionality? So that has built-in functionality, and we're just going to replicate that in code form. It's only 2 lines of code. So we take x plus equal length the, I can spell length the x, SPD, comma, direction. Okay, and that's it. And then y plus equal length the y, spud, direction. Okay, and that's absolutely it. So we're moving our x by an amount in a given direction, okay? And then moving our y by a certain amount in a certain direction, okay? Hopefully you remember how length x and length y work. They return the specific component, so it returns exactly how much in the y coordinate we need to move in order to move x amount in y direction, okay? And how much in the x axis we need to move that amount in that direction, okay? And then both together adds up to moving from one place to another. Actually, really simple stuff. Cool. So that means now we've got complete control over when our speed is applied, and we're now applying it before doing all of our collisions. So we move the bullet and then check for a collision, and then if that collision happens, destroying the bullet. So we should see now, if I run the game, what should actually happen is we should see our bullets disappear a little bit earlier than what they normally would. So if I pick up the gun and I shoot the wall, you can see that, yeah, so it looks a little bit like they're just sort of disappearing on contact with the wall, because they are. The moment they're hitting the wall, they're moving, finding that collision, and then being destroyed. So we're not seeing that final frame of them anymore, which is what we kind of set it up to show us before when we didn't have this hit spark that we were going to apply, okay? So if I close this now, what I want to do is here, when we collide with the wall, instead of just destroying ourselves right away, I'm going to open this out into something a little bit bigger. And what I'm going to do is, at the bottom here, I'm just going to write instance. We are going to add more stuff in here eventually, that's why I've added those curly braces. I'm going to do instance change hit spark true. Okay? So what that does is does exactly what you might expect. It changes our instance from an instance of one particular object, which is currently OBullet, into an instance of another object, which is instance OHitSpark. So it changes its sprite index and all the stuff that comes along with that particular object. And then in here you can write perform events, and that's whether or not to perform the destroy event of OBullet and the create event of OHitSpark, as if you were destroying this object and creating a new one. Okay, so you can put that as true or false. So I put it as true because we want the create event of OHitSpark to run. Now, there is some more stuff we're going to put in here, but let me just show you exactly how this would look first of all. So I have to run. The problem with putting this gun over here now is I actually have to pick it up every time. There we go, pick up the gun. You can see these bullets now have a cool hit spark effect when they get destroyed, but the problem is they kind of go into the wall a fairly significant chunk. It's because of just like how fast our bullets move, and it's just they find a collision, but they don't do anything to sort of position themselves at the wall and so on. Some of them actually look really spot on there, but that is just entirely luck. That's just getting really lucky with where the collision happens to be taking place. So how do we fix that? Well, what I'm going to do is, assuming once we've found a collision, what I'm going to do is back out of that collision until we're right at the edge of the wall, okay? This is a very simple way. It's not going to look perfect, but it will look a lot better than what we have now. So I'm going to do while place meeting, x, y, o, wall. If you can come up with a quick, easy way to improve on the look of what I'm going to do, by the way, be sure to post it in the comments below. That'd be cool to look at other people's takes on this kind of thing. But what I'm going to do is a quick while loop. Oh, no, I'm not going to while loop instance change. Bring that out of here. We do that afterwards. So while we have a collision with the wall, which we know we do because we're here in the first place, we're going to move ourselves backwards. So remember up here, this is how we manually move towards our direction. We're going to move away from our direction. So I'm going to copy this chunk of code, paste it in here, and just tab that a couple of times. There we go. And instead of moving by speed, I'm going to move by 1, and I'm going to change plus equal to minus equal. Okay, so we're going to subtract this length to x and this length to y from it, which was going to move us in the opposite direction. Okay, I could have also, if I wanted to, just change this to -1 and kept that as plus, but whatever. A quick spelling tip as well while you're doing this is a very common error I make, and it can cause all sorts of wild, unpredictable behavior, is to have forgotten to change length to, like, to have written this. It takes forever to spot as well when you've accidentally written length to x twice and one needed to be length to y. Keep an eye out for that, because I make that mistake all the time, and it always takes me forever to track it down. I'm just like, why isn't this doing what I want? And then it's just that one letter. Anyway, sorry, getting off topic now. So while we have a collision, we're going to just move 1 backwards in the direction we came from. Okay, until there is no longer a collision, or no longer in a wall. Okay, you might wonder what's stopping us getting an infinite loop. Well, in theory, no matter how thick the wall is, eventually the wall has an exit, right? So we should always always come out of that, so the while loop is reasonably safe. I'm also going to change speed to be 0, which is kind of just a formality really, because speed doesn't actually do anything in hit spark. But just in case, you know, just be careful and just reset our variables correctly. So, instance change hit spark to, yeah, all that is correct, I think. So now if we run the game, we should see those bullet sparks. I'll go pick up the gun. Chink. Bam, 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 bam. You can see they're now pretty much just at the edge of the wall. One thing with them is obviously they look a bit weird at angles, but I mean that's just down to the aesthetic of how you want to draw your hit spark. I could write in a bunch of code to like do the direction to cardinals. It's kind of a thing I did in PokePoke, but I don't think that works as well with these kind of bullets. So I'm just going to leave it as this for now. I think it looks okay. I think it looks pretty good. Down to you guys if you actually want to implement this or make it look how it does or change how it looks and so on. I think it looks pretty okay. Cool. So hopefully, as you've seen from our hit spark, it's really cool to be able to write an object with animation end instance destroy to do a cute little effect, and it can be used for all kinds of things. And I'm going to demonstrate that with an object I made earlier called Dust. Okay, so I've got a new sprite up here which is just a white circle that slowly degrades into nothingness, and I call it S-Dust, and it's super useful for creating all kinds of little explosion effects or dust when you land and all kinds of things. I stole this effect and this idea of just doing a simple little object that just ends with animation end instance destroy from, I believe, one of Managor or Daniel Linson's LD games, because obviously all the source code for those is available. I went and had a look how he did some things, and I noticed the use of this dust object that just was a very similar sprite of a white circle. It just disappears into nothingness, use animation end instance destroy, and I'm like, wow, you can use that for all kinds of things. So I did. I started using it myself, and it's really useful. It's really simple object layout. I'll leave the code on screen for a little bit. You can always pause, copy this down, but I'll go over it very quickly. We set up an image speed to randomize like how the dust is going to kind of animate over time, so each one is slightly different from the last. We also randomize which frame it starts on, so by starting from, well, we can start from like any number of these different sprites, and we can vary that as well. Randomize from 3 to 6, let's not have that, let's random from 0 to 6, so we don't want to, that completely skips out the first 3. We want to be able to actually use those. Let's go from 0 to 6. HSP and VSP, which we're going to use to move around, just random between -2 and 2, so that they sort of move in a random direction by default, and then when we create them, we can manipulate that. Image X scale, image Y scale, so we can also just like choose returns a random value out of the values that you provide in the brackets. You can provide any number of them as well, but I've just given 1 or -1, so just either flip it one way or the other, which will, you know, either flip it upside down, flip it over. Again, just to add a tiny amount more randomization to how these look. Then the step event, I'm just going to move them, just x plus equal HP, y plus equal VSP, and have those speeds degrade over time. So they move and decelerate. So go fast and then slow to a halt, okay? And they'll move at an initial random speed. And obviously they'll be animating over time at a semi-random speed, and when that animation ends, destroy the instance. And there we go, a really simple, lightweight dust effect. Obviously you don't want a million of these, because as I say, objects can get kind of heavy, but as a cheap and dirty effect, it's super useful, super awesome for doing just a little quick particle effects on things. If you're doing lots of complex particles, you probably want to look into a proper particle, like the built-in particle engine in GameMaker, or at the very least doing some sort of batch drawing thing where you use one object to sort of manage the positions and draw them all at once, rather than using an object for each individual particle. Okay, but for quick little dust effects, this can actually be super useful, and works very long term, and the performance impact really isn't all that much. So I'm going to show you a very quick use of this now, and then a thing for you guys to go ahead and do is go away and think how else you could apply this, because there's a million effects that you can apply this to and make it look really good. I'm going to make it happen when the player lands. So when they do a jump and when they land, I'm going to catapult out a bunch of little particles. So I'm going to go into the step event for the player. I'm going to scroll right down to the bottom. in our animation section, we have a handy convenient section here where we've worked out if the player has just landed. We needed to do this for our landing sound effect. So we can piggyback off of this and put in some code that's going to create some dust. I want to create a bunch of them, so I'm going to use the repeat function. Repeat 5. So everything that we put in these brackets now, we're going to run this section of code 5 times. Okay, you can put variables in there as well as usual. And what I'm going to do is I'm going to type with instance create layer. We're going to create this object at, oh, go away syntax errors, let's move you out of the way. We're going to create this at the x position of x, wherever our player is. bbox of bottom, this is a new one I don't think I've used so far in this tutorial series. Where bbox stands for bounding box, okay, so the collision box of the player. bbox bottom returns the bottom of that collision box. There's also bbox left, bbox top, and bbox right, which returns those coordinates. So left and right give you the x coordinates of the left and right, bottom and top give you the y coordinates of the top and bottom of your collision box. Really, really handy for doing lots of different things. I believe it calculates them every time it's called. I could be wrong about that. So if you're going to use it a lot in an event, it's worth putting it into a variable, but we're just using it the once here, so it's not too bad. The layer, we're just going to put it on the bullets layer. Why not? It's probably a bit lazy. We should probably refactor the layers at some point in this, but it'll do for now. We'll put it on the bullets layer and we'll call it the object we're going to make is odust, okay? And we've done a with the ID of the instance that this has created, okay? So with that object that we've just created, I'm going to set VSP to equal 0 because we're going to land on the floor. I'm going to want the dust to spread out kind of sideways from the player, and since it has a random horizontal speed and vertical speed already, it will do that. But whatever random vertical speed we have, I'm going to set it to 0 so it doesn't go up or down, okay? And that's really all there is to it. So if I run the game now, we should see it right away as well. We'll just when I land, you can see this dust popping out of the player now. Really nice little subtle effect, and it's randomized and nice as well, so it looks kind of cool. One little thing you might want to look into with this is obviously now and again, even though there's five of them, so most of the time they're going to get a nice spread left and right. But now and again you might get all 5 going to the right or all 5 going to the left. It might be worth looking into how you could use the with statement we've used here to manipulate that in such a way so that we always get an even spread of left and right. If you think about that and think about all the code you've learned, you might work out a way you can do that. Or you might just like it like fully randomized. So there's other things you could do here. You could create one for when you jump. You could try that. You could create it for when you walk, just every now and again, every few steps, kicking off a bit of dust. I'll leave you to experiment with that. It's really, really useful. In fact, you can use it for when things explode. You can make bigger ones and so on. Do whatever you like. Anyway, I hope this has been useful for you. Hope that gives you some inspiration on how you can use really lightweight particle style objects to do some really cool effects. And I'll catch you guys on the next part. Thank you very much for watching. See you guys next time. Thank you all very much for your patience over the last few weeks. I know there haven't been that many videos, I've had a lot of different things going on, but we are now back into the full swing of things. Thank you, especially as always, to all of my Patreon supporters, without whom none of these videos could exist, and a super special shout out in particular to the following: Mark Lintz, Dan, Run, James Grumley, Mark Day, Cody Hodkinson, Adam, Rovan Darlan, Harold Gidry, Valp, Matt Coate, Sam Stallion, Lewis R. Pereira, Nick Slabish, Stephen Hagen, Michael Ward, Jason McMillan, Edward Lako, Jonathan, Robert Churches, Owen Morgan, Zenan May, Turtle Time, Bowser the Dog, TJ, Marcel Joshua Gazinga, and Patrick Guffey. Thank you all so much for your support, and I'll catch you all next time.